Have you ever wondered about the environmental impact of cloud computing? It's a question that's more pertinent than ever in the age of digital transformation. Today, we're going to delve into the world of sustainable cloud computing, a practice that's all about using cloud resources in an environmentally responsible manner. First up, let's talk about energy efficiency. Data centers, the backbone of cloud services, are notorious for their high energy consumption. However, the future calls for a shift towards energy-efficient practices. Innovations in cooling, power management, and hardware efficiency are crucial. Take Amazon Web Services, for instance. They're on a mission to power their data centers with 100% renewable energy, investing in wind and solar farms. Next on the agenda is the concept of virtualization and resource optimization. It's all about reducing server sprawl and minimizing resource waste. Google's Borg and Kubernetes are prime examples of container orchestration systems that optimize resource utilization. Now let's move on to green data centers. The idea here is to construct data centers using sustainable materials, employ energy-efficient cooling systems, and harness renewable energy sources. Apple's data center in Maiden, North Carolina, for example, is powered entirely by renewable energy. Another aspect to consider is sustainable hardware. The development of energy-efficient processors and hardware components, including data storage devices, is key. Consider Amazon's Graviton 2, which employs energy-efficient ARM-based server processors. Carbon offsetting is another significant aspect of sustainable cloud computing. Cloud providers are increasingly investing in carbon offset programs to offset the emissions generated by their data centers. Microsoft, for instance, has committed to being carbon negative by 2030, which involves removing more carbon from the environment than it emits. Water usage reduction is another crucial factor. Given the vast amounts of water consumed for cooling in data centers, water-efficient cooling solutions are vital. Facebook's data center in Sweden, which uses outside air for cooling, is a great example of minimizing water usage. Sustainable sourcing and recycling is a further consideration. It involves responsible sourcing of hardware components and recycling old equipment to reduce electronic waste. Google, for instance, is committed to responsible sourcing and recycling of electronic waste. Finally, we must consider the role of public awareness and regulation. Governments need to enforce eco-friendly practices, and raising public awareness about sustainable cloud computing is vital. The European Union's Green Deal and its data center sustainability goals are a perfect example. In conclusion, the future of sustainable cloud computing depends on collective efforts. As the demand for cloud services continues to grow, it's essential to ensure these services are delivered with minimal environmental impact. This involves ongoing innovation in energy efficiency, resource optimization, and sustainable practices, along with regulatory measures to incentivize eco-friendly operations. The cloud might be virtual, but its impact on our planet is very real, and addressing it is a responsibility we all share.